Now, the software development management models, how are we gonna manage the software development process? There are different models for that. The very first model that, not actually a model, that's what happened. It's just, okay, let's build it and use it. And when problem happens, keep fixing until eventually it's gonna be a legacy system. It's gonna be obsolete. That cannot be fixed anymore. So you retire it. Okay, that was a very, very old. This is how it started at the very beginning, when the software systems were very simple. It was working then, but the more the system become complicated, the more complicated the process has to be. Okay, so this doesn't work anymore, obviously. So they said, okay, now we're creating a system. Let's treat it as an engineering system. That's how it's not software programming anymore. It's software engineering. So let's try to model or use the model that is used in other engineering disciplines in order to build software systems. So one successful model in other engineering disciplines is the waterfall model. So the waterfall means just like when the water is falling, the water doesn't go back, right? So when you're planning, you're budgeting, everything, it's a waterfall. So you have some time for requirements analysis. And when this time is done, we're over with that. We just now talk about specification. And here, this is the outcome from every step. Okay? So here we have requirement definition. And then we start creating specifications, more specific models for these requirements. And then we start the design. And then we start coding and testing and implementation. Now you see this arrow that's coming back, that was added later. At the beginning, it was just one way kind of model. And there is no going back from one stage to the other. Planned, there's no planned or budgeted going back to any stage, okay? Obviously that didn't work. So they said, okay, we need some what's called refinements. We need to go back a little bit in order to correct mistakes and stuff like that. So they created that waterfall with a splash. So as if it's the water is splashing back. So a little bit of planning for just going back to review or refine the previous step. Also, that didn't work. Again, that was not sufficient. So why is it not sufficient? I mean, it's working perfectly for other engineering disciplines, but it's not working for software engineering. Now, there are two main problems for that. You see how it is in software engineering? First problem is that our understanding, so the user describes to you what they need, what needs to be done, right? The user themselves not really fully understanding of the problem. They describe it generally, but it's not 100% accurate understanding, and it's not 100% accurate description to you as a developer. Now, you as a developer will take it with your interpretation too, so you're gonna add your layer of confusion on top of it. So understanding of the problem itself is very problematic. Okay, so that's the first problem. Now let's say we figured out a way that we have a accurate description of the problem and we fully understand it. Now what happens is that over time, the problem itself changes. So it's not like you're building a bridge and you have to deal with the laws of physics. It's not like you're building a car and you have to deal with metals and, well-known components. You're talking about software system that has people involved and like a lot of ambiguity there. So the problem itself changes over time. So even if we just assume for the sake of the argument that we have full understanding, now that full understanding will become obsolete eventually because the problem itself is going to change over time. All right, so that rigid waterfall model is not gonna work. We need something else. So what do you think can we do about this? What can we do? What could be a better way to deal with this? What do you think? So obviously, yes. Yes, we need adults to go different steps. We don't want to have a very rigid waterfall. Well, how can we do that? In the agile approach, yes. So we need some way to have some flexibility in the activities, and we get feedback from different activities to the others. So first attempt was that, just one note, the waterfall model is not completely out. It can be useful if you have a very stable problem. So let's say, for example, you are building a library for mathematical calculations. So mathematical equations are very well established for a long time, so the problem itself doesn't change. So there is a chance you can use a waterfall model when the problem is very limited and is very well established, which is not the case in 99.9% of software systems. So first attempt, they started the incremental model. So in here, we said, okay, we're gonna have to start with some requirements, so all the requirements have to be collected first. And then we're gonna have some, we don't have to do all the design and all the building at the beginning. We have one increment with some aspects are designed and implemented. And then we use that as feedback to design the new increment. And then we use that as feedback to design the new increment and so on. Okay, so that's one approach. Which was a little bit better, but still not perfect. What do you think is the problem there? What would be the problem here? Why is it not perfect? Well, it seems like we are going back to different stages. Yes?
Probably waste a lot of time.
Waste a lot of time in what?
If you're building things that you are like certain are what the user wants, you're going to be wasting more time than if you like did it smarter way.
If you did it what?
If I build the first increment and that's not like the whole project, I might be adding like tech debt of like I might not do it like part as far away, and then parts of it you might have to throw out if like that increment is only 50% correct.
Okay, you're getting ahead. You're talking about throwaway prototypes. We're gonna get into that. Yes. So that's partially that there is a version of it that is a prototype that would be problematic in that. What you mentioned, it could be a waste of time. But what we see here, so we said we want to go back to different steps, right? There's one task that there's no going back to it. Which one is it? The requirements. So there's an assumption here that all the requirements are collected before we start the increments. And then all the increments are going to build on these requirements. Now that, yes.
The whole requirements change over time.
Yeah. Sorry? Yeah, the requirements will change over time. That's the problem. The requirements change over time. So we can't just assume that we have collected the requirements one time and that's it. We cannot do that. So that doesn't work because of that assumption that the requirements are collected and reliable before we start the increments. That doesn't happen. Okay, so another approach is the prototyping. So when you're collecting the requirements, you create a prototype. Actually, sometimes the prototype is created to capture the requirements. Okay, and also it can be used to explore a certain concept or experiment with a different, like let's say you have a new idea, a new algorithm, and you don't know whether it's gonna work. You want to experiment with it. So before you go through the entire process and build the entire system, you can build a prototype that is used to test that concept. or test that idea. Okay? So there are different types. So prototyping could be an actual development. So you create an actual system that is a prototype. Or you can create a throwaway prototype. Okay? So you don't really do any proper designing or any proper diligence when you create a prototype. You just create it for the sake of collecting the requirements, or just for the sake of using it to understand what is needed, and then you throw it away with that intention. You intentionally don't design it well. You intentionally just create it very badly so that you don't spend a lot of time on it, but at the same time use it to collect requirements. Okay? Now, there are some advantages to that throwaway, that you didn't do a lot of diligence, so you didn't spend a lot of time. But even though the little time, we've seen that all the advantages has an equivalent in the disadvantage. Yeah, you saved some time because you didn't do a lot of like planning or designing or anything. But if the customer when you show them the prototype, they said, okay, this is what I want, you have to give me that. Now you're gonna be in trouble because you didn't spend a lot of time building it properly. And in order to build it properly, you're gonna have to spend other extra time. Okay, so there are some advantages of the throwaway prototype. Is just, yeah, you save time, you have something tangible, you can see what is it that you're talking about. Both of you can see what are you talking about. Okay, you don't wait until the system is fully built and then realize that this is not what they want. But at the same time, you may need it, but you didn't spend a lot of time designing it. So it's not well done, but now needed. So you're gonna have to redo the work. Okay, or sometimes it can send a wrong message to the customer. Okay, and it may, everything has advantage and disadvantage, and you have to understand that. Okay, if you're planning to use it later, then it may be worth it to invest some time in well designing it. Okay, but the prototype can also be done in an evolutionary way. So instead of having it being done with intention to throw it away, we're just gonna we're gonna properly build part of the system, and we use that as a prototype, and we build on it incrementally as we go. Okay, so here the problem of having all the requirements set at the beginning is not there anymore. Now we have you can see the arrow is a little bit larger in the requirements, so we have to spend extra time in the initial stage of the requirements to collect as much as we could, and then some extra time to look general plan for the entire system. And then you start by one portion, system version, this one portion. And then you go through the entire process, starting from the requirements. When you start to create the second version and the third version and so on. Okay? So far that seems to be the best way. Now the agile approach is pretty much an evolutionary prototyping. Okay? But the agile methodology is not just a management model. It's much more than a management model. So if you look at it as a management model, it's pretty much for evolutionary prototype. But actually, it is a methodology. It's a way of thinking. It's not just a management model. It's a mindset. Okay? So you take the evolutionary prototyping and add the agile mindset, and you have an agile methodology.